Why yes, it's exactly as I thought. I'm Mr. Crispin here once again, and welcome to my workshop. In today's video I'm going to be progressing with my locomotive cylinder blocks, so without further ado, let's get straight into it. The purpose of today's video is to make this bit go on this bit, and that is of course the same on both of these. For anybody new, these are my locomotive cylinder blocks, and you can see the manufacture of them in the video series Machining Cylinders, parts 1 to 8. Now the crucial thing here is the alignment of the slide bars, so I just push the piston forward to demonstrate. The slide bars have to end up parallel to the bore and piston in this way and in this way, because it's basically going to act as a guide rail, and so it needs to be in line with the axis that the piston is going to go in and out of. Now to try and establish what's going on here, I've mounted the cylinder covers to the cylinder block, and I'm going to go on the surface table and take some measurements to see if I can predict what's going to happen, because of course it's all going to be down to how square this face is, because that face is going to be what's sort of dictating the angle of the slide bar. Okay, that's 0 in this corner, so coming across it's pretty good. I've only got about 2/10 of a thou there, so that's roughly 5 microns, and then front to back I've got a couple of tenths as well. So overall that whole surface is actually within about 2/10, 5 microns, which is actually better than I could have anticipated. So no need to do anything with that one. Now let's see how the other one compares. So I'm not going to touch the dial, so we'll see how they compare in terms of overall height as well. So this is looking about a thou lower. Okay, but it's consistent with a thou lower. Now getting on for, okay, about 2/10 again, just over 2/10. I'd say probably verging on 3/10, so basically very similar. So what I'm going to do is proceed with putting in the tapped holes in the top of here for attaching the slide bar, and I will do that by removing these and taking them both to the milling machine. So to the milling machine I go. Just one final detail. As you can see, I did the profile here with a milling cutter that left a corner radius, and as a result I will have to do something about the fit, because obviously at the moment square corner on the slide bar, corner radius on the cover, there is an interference. So what I'm going to do is file a clearance radius on this corner, but that is a minor but important detail. Now if I had some recollection of the relationship between this hole pattern and this face, I could maybe use dowels going through the holes and then some sets of slip gauges to set it, but seeing as I don't have any recollection of that, I'm just going to deal with what's in front of me and use a clock to get this surface square. So initially I'm going to set this in the vise, and I'm just going to use a parallel to give me some indication of squareness or parallelism before I go to the extent of clocking it. Now I find it helpful in these scenarios to get the parallel as parallel this way as I can. If for instance I was to put that at a funny angle, when I then look from down here, it looks like the part's out of line, more than it actually is. So a bit of care to keeping this parallel at the start helps for a bit of alignment. Now I'm just going to use my eye to set this to what looks right. Okay, so let's now get a clock and proceed to make a fine adjustment. Right, this is a 2 micron clock, and across the face I currently have 80 microns, which is just over 3 thou. So I'm just going to very gently slacken the vise, and wants to roll towards me a touch. And we're down to just under 1,000, so it just wants a touch more. Next up is the step of establishing a datum, and if you want to know how you should do it, then perhaps look in the comments, because somebody there normally knows, but I'm going to do it using a DTI, as you can see in the spindle. And first of all, I'm just going to set this by eye to get roughly in the middle. Okay, so that's definitely going to make contact, maybe a bit heavy contact, but we'll see. Yes, that's a touch heavy, so what I'll do, now that it's in contact and roughly in the middle, I'll just offer this up so I'm getting a reading, and then she goes. Okay, so a high point there, just bring this into the middle. Now it's very important you find the high point in both directions of travel. So first of all this one, and now that's there, I can assess the up and down, and that is my point of reference. So that both matches out in that way and in the vertical. Okay, and now I'll bring this round, come down again, right, so that's point 456.7, so I shall back off point 1, 2, 3, 5 roughly, and I'll just re-zero this again with a minimal. Okay, repeat the process. That little step there was to get the minimal loading on the needle. So now 0. Okay. And that's got me at 40 microns, which is a thou and a half. So I'll just split the difference again, going in this direction, and that should be me bang in the middle. Do a double check off camera. Okay, so that's got me there. So I'm going to set my table coordinate to 0 for that axis. Now I've actually got a freebie by doing this as well. The piece of geometry I've been clocking over at this point here measures 1 inch. So when the needle is reading 0, the needle is actually ½ an inch from the centre line of the spindle. So what this means I can do is now drop down, spin it round to this position, and I can edge find this direction, bring it into a appropriate spot, and I can do the same this way. So I'm going to feed in, find the spot, that's it, and now the spindle centre line is exactly ½ inch back from this face. So I can again set my coordinate to 0, and then I can move exactly ½ inch over that way, bearing in mind the direction of the backlash. So let's go to 0, and now I'm going to go to 12.7 millimeters. So that's 12.5.7. That should be 12.7 millimeters exactly. So I'll re-zero at that. With that done, the spindle is now right over the middle of the component this way, and it's in line with this face of the component in this way. What I will do is use the scales on the machine to go to hole 1 and then hole 2. So as I proceed, this is how the positions of the holes are being established. Ahead of moving to position by means of coordinates, I like to carry out as much foolproofing as possible. So what I'm going to do is offer this up to where it hopefully will end up, and I'm going to mark through what that actually looks like. Now I've got this, if the centre drill lands wildly outside of the black area, then I know I've done something wrong and I need to go back to the drawing board, but hopefully the centre drill will land roughly in the middle of those dots. I am just finishing these off by hand now with a plug tap to get the full depth of the threads. The two-step drilling process using a small drill bit then a larger drill bit was because on these little BA threads, the actual radial section of threads is so tiny that if the drill bit was to cut over size, you actually lose quite a lot of the threads. This is 5 BA for instance, and the radial section on either side of the tap is only cutting about 1/4 mil, 10th thou. So if I was to go straight in with the full size drill bit and it was to cut over size by a bit, you've actually lost quite a lot of your threads. So I tend to use a bit of a two-step process. Anyway, I must concentrate, but I will reconvene at the bench once I've got 2 fully tapped articles. The next thing to do is sort out this clearance issue I mentioned earlier. Square corner on here, corner radius in here. At the moment there is some fouling geometry. So to sort this out, I'm just going to file a radius on this corner, and from where you're looking this will look rather horrible, but fear not, the jaws of this vise are smooth. Oh, I do need to remember to get some soft jaws. Right, I'll just file this on. With that now done, you can see that the 2 square faces are now in contact, and the radius just has some slight clearance to keep it from causing trouble. So both cylinder covers now have their tapped holes in, and they're also both back on the cylinders. I'm going to bolt these on and then start some alignment checks. So first of all, could the left hand slide bar come forward? That's this one, and hopefully I haven't jumped the gun here and put them on in an inaccessible position. I'm going to take the covers off again and then put them back on again because I can't get that on. Okay, that's them on. Now what I've discovered is actually my first assembly conundrum. Now this isn't a problem that needs solving today, but it does need solving at some point. What I've noticed, and as you will be able to see yourself, is that one of the cylinder cover holes has been obscured by this. Now I was sort of aware of this, and I was going to put a little slot in the end of the slide bar such that I could bolt the cover on, then fit the slide bar afterwards, but obviously with this latest development I'll have to rethink that. Perhaps I can get away with a shorter bolt, but it's a bit close. Okay, before I get too concerned with setting them this way, I'm going to have another look at how parallel the slide bars are to the bore this way. So I checked earlier the length of that little flat, and although that was good, that error magnified over that length may well show more error. Okay, so first of all, see if I can get a repeat without crashing. Okay, so this end is 0. Now let's come down here, and I've got about between 6 and 7 thou lower. I have carried out the check on both blocks, and I've also done a few sanity checks, like turning the parallel round to make sure that wasn't an influence. Getting a bit oily here. Now my findings are as follows. On one I've got 0, -2, -6, and on the other I've got 0, +2, +5. I've decided I am going to do something about this, so I've come up with a little plan, and it's going to involve the surface grinder. Here at the surface grinder I have placed a feeler gauge under this end of the vise to tip it up, and I've added a bit of support with the V-block, seeing as I've lost the large contact surface underneath. And what this has done is allowed me to replicate the error I'm seeing on the surface table, but in the machining setup. As you can see, at this end I have -6 thou, and down here at the 0 end I have 0. So now all I have to do is remove the slide bar, regrind the top surface underneath, and that should have taken the error out. So starting with this one, which is the one I just did on camera, let's reset 0. Okay, so 0, and I've managed to maintain parallelism across this way, which is good. And coming down here I now hope to see 0 rather than -6. Whoop, got overexcited there. Yep, good. And let's now check the other one without disturbing the settings. This one's had exactly the same treatment. So, okay, just a touch higher. Parallelism is still not bad, and overall got about a thou low. A very quick recap on what I've just shown there. So I built up the assembly, checked the alignment, and then wrote down the errors in the locations that I was measuring. I then took that assembly and put it on the machine and replicated its alignment such that I measured the same errors in the same places. Once you've done that, assuming the machine is square, you can reskim the surface and it takes those errors out, and that works just as well on milling as what I've shown here. Now if you were doing it properly, you would have factored in some excess material on the face you were working on. Here I've just reskimmed what was in theory a nominal size, but if you were actually building this into your process, you might have left 0.1 of a mil on or more to give yourself the wiggle room to take the error out and then bring it down to finished size. With the slide bar positions now set in this direction, I'm going to set them in this direction, and for this direction I require again that the slide bars are parallel to the bore, but also that they are in the right position. Going back to this earlier direction, the position was actually defined by that face because it bolts to it, but here there's some float in the position as it stands because these are clearance holes and therefore not hugely constraining. So to work out the position from the table, I have done some sums, and this is what I've arrived at. So clearly the slide bar should be on the centre line as viewed from this direction, and what you can see here is the datum face here, then the bore which is here, and then in red the slide bar. So the centre of the slide bar should be on the centre line of the bore. Bit of simple adding and dividing. So here's the bore diameter. Half of the bore diameter is 8460, so therefore 8460 added to 654 gives me here to the centre line, and that comes out actually as 1.5 inches. Then half the width of the slide bar, that gives me overall 11875 from the bottom. So this dimension here from the table to the underside of the slide bar should be 11875, which is actually 1 3/16 of an inch. So how am I going to do this? Well, you guessed it, I've got two sets of slip gauges, and I'm going to slacken the bolts and set these under there. So let's see if I can do this without making it look too complicated. So I'm going to slacken these off. Okay. And let's put them on this side, so I'm going to ease that up a bit. They're going to go in there. It's going to sit down on them. Then I'm going to push it fully this way so that there's no gap between the end of the slide bar and the cylinder covers. So that's there. And with that all held down, I shall now re-snug the bolts. Okay, see what that I think what we'll do is bring this over to check. Just adjust it in. Right, I'll repeat this process I think and make a few tweaks. All bolts are now tight and I have sorted these two out on both of them using the same method, and I'm going to call it quits at that. With the parts well aligned, I now want to do something to give me a reference such that as I disassemble and reassemble these pieces going forwards, they go back on something like they are here today. First of all, I thought of putting some taper pins in. So here's a tapered pin. I could put a couple in here and here, but then I thought, well, that's going to be a blind hole. What if the taper pin gets stuck down in there? I also was talking to a friend of mine, Dave Ticehurst, and he said you could put some keyways in, so I could actually put a keyway in underneath going that way or perhaps that way. That would give me a good alignment. But then as I was considering the other elements of the assembly, I remembered that there's some bracketry that bolts on here and goes to the chassis. So actually all I would really need is a dowel here and a dowel here, and then it's got it. As once fully assembled, it can't move. So ultimately a dowel here and a dowel here would lock everything in position. But of course, for now at least, the cylinder blocks are just going to be their own entity, and this chassis piece won't come till later on. So what I've decided to do is put a dowel here and a dowel here, and that way the piece is reasonably well locked in, and I can improve it in the future with a dowel further out. The reason I say improve is because although I'll still have two dowels which in theory lock everything together, the tolerances required, to make the dowel go in sometimes allow a small amount of movement, and as we saw earlier, only a small amount of error over this distance led to -6 by the time we got down here. The dowels will face the same issue. Even if there's a few tenths of play here, that will be a larger amount down here. So I'll use two dowels for now, and with the future improvement of a more substantially spaced dowel later on. All that remains is for me to pick a suitable pattern to put them in on. I've decided to go 1, 2, 3, 4. I did think about going 1, 2, 3, 4, but then I've still got this unresolved issue of the fouling bolt head, and if I stick a dowel in here I'm further constraining the matter. I did consider going 1, 2, 3, 4 corner to corner to give me the biggest span, but getting the tooling into here becomes a bit tight, so I'm going to keep it simple, 1, 2, 3, 4. The tape on the front is just to take up any small discrepancies in surface texture between the two, because I've got a good hold on both of them as is. Right, first of all, some edge finding. I have had a small mishap. Now often when I have a mishap it's of course done deliberately to enhance a demonstration, but what I've done here falls into the category of a silly mistake, and basically as I was working and progressing I visually spotted something that didn't look right, and as I proceeded to then check it, my eyes turned out to be right. The holes were definitely out of position, quite unsymmetrical and different on both components. So I did some rechecking, reused the edge finder, rechecked the calculations, had another go, and they were even further out. To cut a long story short, somebody hadn't tightened the vice up properly and the parts were just moving around in there. So definitely silly mistake. Fortunately, by visually checking, I managed to catch the error before it got to the point where it was unresolvable, and what I have done is I've just had to go up a bit in size, so instead of a 3/32 diameter I'm having to use a 1/8, so not the end of the world. We'll pick up now from the finish reaming operation. Typically with reaming no packing is required, but with these smaller diameters I like to just make sure there's somewhere for the swarf to go. A close-up of what I've just been discussing can be seen. So as can be observed, I got very close to having a bigger mishap, but I just about got away with it. And the idea, of course, is that the dowels go in here, and then this sits on like this. Oh, I've also done that, by the way. I decided to put a scallop in the end, such that when I assemble this, you know, in the closer to the final time, I'll put a captive bolt in there that's free to rotate, and then the whole thing will be offered up to the cylinder block. That's my current plan anyway. So this goes on here, like that, and I shall assemble the two of them and we'll have a little look at the end. There can be seen the captive bolt idea. You can see in front of that bolt hole there's now room for a head to spin, and that concludes the mounting of the slide bars. In my next video I will be progressing further with the cylinder blocks. So that's it for today. In conclusion, there are perhaps a couple of takeaways. One, on the technical method side of things, could be the procedure of checking a part's alignment or an assembly's alignment, writing down the errors and then putting it back on the machine, replicating those errors and taking them out. That's a handy one to have up your sleeve. Also, from the point of view of machine shop practices, regularly visually checking the work and double checking measurements can save you getting in a pickle. If I had proceeded much further with what I was doing there, I think I would have ended up with some kind of major compromise. However, by visually checking regularly and double checking dimensions, although I still made an error, I managed to catch it and rectify it and end up with something that was fairly in line with my original intentions. So apart from that, I'll say thank you for watching. I hope you found it interesting and see you on the next video.